Hello dear student, how are you? I hope you are all will be fine. I am also fine, thank you. Let's start today's topic. Today is lecture number 15 of nucleophilic substitution reaction. And today lecture we will be studying about the NGP. NGP shortcut NGP. NGP means neighboring. NGP means neighboring group participation. Neighboring group participation. Group participation. Today we will be studying about neighboring group participation, that what is the effects of different groups that are attached in the same compound as a neighbor to the leaving group. Like this is one compound having, this is the halide ion, or you can say that this is the leaving group. So this is the leaving group. When here is also attached some groups that can also be like act as a electron donor, or you can say that nucleophile means internal nucleophile. So it will be this step. Due to this step, this is the neighbor group to this living group. So that's why this group will be called the, what is the participation, what is the effect of this neighbor group to the living groups. Today we will be studying these effects. I hope you will be cleared my points. So, how can you define what is NGP? How can you define? How will you define the NGP, neighboring group participation? Let's start. In organic chemistry, NGP in organic chemistry has been defined by IOPIC as the interaction of a reaction the interaction of a reaction center with a lone pair of electrons present in a sigma bond or pi bond contained within the parent molecule but not conjugated with the reaction center. What this means? It means that when there is some groups attached with any compound, as I told you before, let's suppose here is one heavy group attached, that is bromine group attached here. Here is also leaving group attached to the another carbon. It will be like that. This is the leaving group that is attached to this carbon. Let's suppose this is OH group. Yeah, let's suppose this is OH group, sir. Or you can say, let's suppose this is fluorine group, sir. This is fluorine group, sir. So when this iodine group attack internally, means it is intramolecular force, it is intramolecular reaction, at intramolecular attraction, one atom of the molecule attack on the another atom of in the same molecule. It will be attack on this carbon. Why it attack on this carbon, not on this carbon? It attack on this carbon because this carbon is electrophilic carbon. Due to high electronegative element attached with this carbon, that withdraw the electron from the carbon and make the bond polarize. So that's why carbon become partial positive charge and getting act as an electrophile. So that's why bromine, the lone pair of bromine attack on this carbon and fluoride ion will be removed. So the next step of the reaction will be like this. This will be like this. The bromine will be attached like this. This is plus charge. Bromine will get plus charge. So the definition, according to definition, the interaction of a reaction center, yeah, this is the reaction center with a lone pair of electron. This is the lone pair of electron interaction present in a sigma bond or a pi bond. Lone pair of electron that interact with sigma bond, yeah, that produce sigma bond. This is the sigma bond that are produced, that are generated by this lone pair. So within the parent molecule but not conjugated with the reaction center. This is the parent molecule. Within the parent molecule, not in the another molecule, not any two molecule, only one molecule will be used in first step reaction, hence rate determining step reaction. So in this step only one reaction, that is intramolecular attack will be occur. Intra means that is inside in the molecules. So intramolecular reaction, intramolecular attack will be occur by the one group to the carbon and leaving another group, which is called the leaving group. But this reaction, but it will be not conjugated with the reaction center, means will have not the resonance. It cannot be produce resonance. It cannot be in conjugation. This means this the bond that are newly produced that cannot be conjugated with the any other atom or any other bond or pi electrons or lone pair. So that's why now here in this case when there is nucleophile of solvents that is CH3OH, that is, let's suppose this is methanol as a solvent. So this methanol can attack on both carbon, and carbon number 1 as well as can attack on carbon number 2. When they attack on carbon number 1, now SN2 process will be produced. The whole mechanism is the SN2 mechanism. So here is CH3, or you can say that solvent attack on this carbon, so that's why the bond will be shift here. When the bond shift here, it means that the nucleophile, or you can say that the nucleophile attack from the back side of the carbon. This is the back side of the leaving group. This is the leaving group. This is the back side out to this leaving group. So that's why you can say that this product will be it generate the product that will be like inversion product. It will generate inversion product, that is CH3OH CBr. This is the inversion product because nucleophile attack from the back side. It can also generate retention product. When the nucleophile attack on this carbon, then it will be produced like that. So that will be inversion. That will be retention product. That will be retention, and the product will be due to this side. This is the leaving group. This is the front of the leaving group. So that's why here it attack from the front side, and the attack are from front side. It is called retention product. So it will be retention. OHCH3. This product is the retention product. So these are which are complete in two steps. In first step, intermolecular attack occur, while in second step intermolecular attack occur. In second step, either maybe the product inversion or retention, but the reaction will be intermolecular attack. That is the attack of external nucleophile, not the internal nucleophile like in the first step. So these are the two products. This is the effect of NGP, neighboring group participation. Neighboring means neighbor are those, in simple word, those that are near to you, that will be called neighbor of you. So this is the neighbor effects of the one group on another. I hope my view will be cleared to you. What is the effect of NGP? The first effect of NGP, it increase the rate of substitution reaction. That is the reaction of SN2. So that's why I am writing SN2 reaction. So it increase the rate of substitution reaction or SN2 reaction significantly. Also, the increase in the rate, it is due to the internal nucleophile. So that's why it is also called enchimeric assistance. The word also used for this reaction is enchimeric assistance. Enchimeric word used. It is the Greek word. Enchimeric means here enchi. Enchi means neighbor, while mer mean part. So neighbor part. Here in this reaction, sometimes rearrangement also take place. Rearrangement can also take place to produce stable. Rearrangement also can take place to produce stable carbocation. It may be also take place, but it will be present of where SN1 mechanism follow, where the reaction follow SN1 mechanism. But here it is SN2 mechanism. in the whole reaction in first step SN2 mechanism for, while in second step SN2 mechanism formula. In SN2 mechanism, first one nucleophile will be attacked on the electrophilic center while the leaving group will be left. So here nucleophile in first step, nucleophile attack on this electrophilic carbon, and while this nucleophile is the internal nucleophile, so it will be called intramolecular because it is the atom, it is the nucleophile inside in the same molecule. While when they attack on this electrophilic carbon, the leaving group left the group. So as at the same time when the nucleophile attack on the electrophilic carbon and the leaving group left the groups, it will be called SN2 reaction. So the first reaction, the first step will be SN2 step, while the second step is also SN2 step, because at the same time one bond will be break and one bond will be formed. The bond that is formed is it is due to the attack of nucleophile, external nucleophile. So that's why it will be called intramolecular, means there is two different molecular attack presents. So here two SN2 steps required. One SN2 mechanism, one SN2 step is single step, while another SN2 step is also required, that is that generate the final products. And second step that will be either maybe inversion product produced or maybe retention product produced. The inversion product will be very rare because to getting the original position of the first nucleophile means when they are attached with the carbon number 1. So that's why the second group, or you can say that the nucleophile will be attacked on the second carbon. That's why a retention product will be produced. So when you do 2 times SN2 reaction, when you do 2 times SN2 reaction means when 2 times inversion reaction take place. In first step also inversion because of nucleophile attack from the back side, while in second step also nucleophile attack from the back side to lifting the groups, to lifting the bond, to breaking the bonds, to breaking the bond, to this bond a nucleophile attack from the back side. That's why this is also the step of inversion. But to original position where the group that are left, it will be the product will be retention product, because to the same from the same position the new nucleophile is also attacked, the new nucleophile also bonded with this carbon from where the one leaving group left that same carbon. So that's why when 2 times inversion take place in the same carbon, that effect that will be always generate retention product. I hope this point will be cleared. Here the one point you should remember, that in the product of the first step, the product of the first step will always be the cyclic product. It will be always the cyclic product, while the cyclic product is also the transition state. It will be also the transition state of the reaction. It will be also the transition state of the reaction. It means that the energy of this step, energy during this period of time, the very high energy will be, the reaction will be increase the very high energy, means it is the energy barrier to the reaction. At this time, to making the transition state of the reaction, the energy will be reached to the peak point of the reaction of the energy graph, energy profile diagram. It means it will be like this. This is, let's suppose this is the energy profile diagram. So let's suppose this is the first position, this is the initial position. So here it will be occur like this. This is the first steps, while this is the second step. So it is the final product. So in first step it is the transition state. So this is the peak point of the energy where energy is too much increase. I hope this point will be cleared. This is the energy and the transition state. The energy of the transition state will be very high, and the energy profile diagram, it will be at the peak point. One another point, the groups that can affect the neighboring group participation are, you can say that those atoms that can act as a neighboring NGP. It will be at also oxygen, nitrogen, X, that is the halide ions, halide groups. X is also here is sulfur. So these all are the effect that affect, these all are the groups that can affect that can also act as a intramolecular nucleophile. In first step, it will be act as a nucleophile inside within the molecule. So that's why these will, it is due to because these all atoms contain lone pair of electron, free lone pair of electron, which will be act as a which will be act to the system as a nucleophile, and this nucleophile will be attack on the electrophilic carbon, like in this position when they attack to this on this carbon, that is the electrophilic carbon. So these all are attack. I hope this point will be cleared. Now I am cleaning the board to proceed the topic. You can take screenshot or you can rewind the video. So let's start. When there halogen is a act as a neighboring group. Halogen is a neighboring group. Halogen is a neighboring group. Like in the reaction, when there is bromide ion, here let's suppose there is bromide ion, this is H, this is CH3, this is CH3, H and OH. O is this strong electron withdrawing group, so that's why they withdraw the electron and getting partial negative charge, while it polarize this bond to produce partial positive charge or to make this carbon electrophile. So that's why this bromine also contains three free lone pair that can be attacked on this electrophilic carbon. So that's why it produced SN2 mechanism. Due to SN2 mechanism, but the attack will be called intramolecular attack here, because inside the molecule the attack is occurs. So now here they produce intermediate, that is bromonium ion. They generate intermediate plus ion, HCH3, H, that is H. So here the another that can also be act as a nucleophile, where you take it as a solvent. So when you take HBr as a solvent, so here the bromine ion will be, this H will be attack on, here the OH is removed, so this OH will be attack on this H and produce H2O, while this bromine ion can be attack on this both carbon. It can be attack on this carbon as well as it can be attack on this carbon. When they attack on this carbon, let's suppose this is carbon number 1, this is carbon number 2. When they attack on carbon number 1, they generate the product that will be intermolecular, because it is between two molecules, that is bromide molecule and also the another molecule, so that is the intermolecular. So the product, when they attack on the carbon number 1, it will be produce the inversion product. Inversion, why it will be inversion? Because it will be attack from the back side. This, the first step is also inversion step. Why it is inversion step? Because the bromine ion, or you can say that the nucleophile, that is intramolecular nucleophile, that attack from the side of the carbon where the OH or leaving group left the group. It is opposite, the attack is opposite to this leaving group, so that's why it will be called inversion. The product will be inversion. While in case of here, when the bromide ion attack on any of the carbons, the attack will be inversion, because from the opposite side, when they attack on carbon number 2, this bond will be broke toward the bromonium ion. So that's why it is the attack from the side from where the bond to opposite from where the bond are broken. Or when they attack on the carbon number 1, they will be attacked from this side, from the opposite side, from where the bond can be break. So that's why both steps is inversion steps. When they attack on the bromonium ion, the final result will be like this: H CH3 Br Br CH3 H. The final product will be this. So let's see that the Br attach the Br is attacked from the opposite side to the original position where the carbon, where the OH bond or where the leaving group left the system. So it is the opposite to this system. So that's why the final product will be inversion product. The final product in the mixture will be inversion product. So it also produces the retention product. When the external nucleophile attack on the carbon number 2, so that's why this bond will be shift toward bromonium ion. This is also, you can say, this is also the transition state. This is the transition state, or intermediate, you can say intermediate. This is bromonium ion. Bromonium ion. Here also inversion take place because the bromonium ion will be attack on the carbon opposite to the bond breaking. So that's why it also produce the bromine will be shift here, CH3 H C CH3 H. The new bond will be produced here. So this is the bond, this is the new bond, that is from the side from where the nucleophile, from where the leaving group left the groups. The new bond will be formed from this side, from the front side. So this is why the final product will be retention products. So this is the retention product. Now here in the solution, inversion and retention both present when they are in same quantity, when they are in same concentration, the mixture will be called racemic mixture. It will be called racemic mixture. Racemization can take place because both concentration, both of the compounds, both of isomers are present, in the form of products. Both of the product of the isomers are produced. So these are the, when halogen is in neighboring groups, this is the reaction of the, when the halogen is in neighboring groups. Second, oxygen is a neighboring group. Oxygen is a neighboring group. What will be the effect when oxygen used as a neighboring group? Like in case of hydroxyl group itself are alkoxide ion, hydroxyl group are alkoxide ion, OCH3, or you can say that OR, alkoxide ion, may participate in the neighboring group. The methoxy group, this is the methoxy group, for example, can assist to substitution reaction through neighboring group participation. This the 4 methoxy alkyl sulfonate. This is in case of, in case of this, in case of this, where here is used OCH3. Here in this case, the reaction will be, the SN2 reaction will be 4000 times faster than the simple, 4000 times faster reaction will be occur as compared to the N-butyl sulfonate. When there is simple butyl sulfonate used, OSO2, there is simple butyl sulfonate. This is very faster, this is very faster when oxygen is a neighboring group or methoxy is a neighboring group used. So let's start the reaction. Let's show you the reaction. When we use 4 methoxy alkyl sulfonate, when we use 4 methoxy alkyl sulfonate, OSO2, this is alkyl sulfonate, this is methyl, and this is OMe, or you can write here CH3. Let's like this. This is CH3. This is not 4 methoxy alkyl sulfonate. This is 4 methoxy alkyl sulfonate. OSO2. This is 4 alkyl methoxysulfonate. 1 2 3 4 5. 4 methoxy alkyl sulfonate. This is sulfonate group. So it is called 4 methoxy alkyl sulfonate. Here in this case the methoxy group have two lone pair. This lone pair will be act as a nucleophile, that is intramolecular attack will be occur. Intramolecular attack will be occur here. Why intramolecular? Because it is due to the neighboring group of methoxy. This lone pair will be act as a nucleophile, that will be internal nucleophile, so that's why the sulfonate group will be removed from the system and the cyclic transition state will be generated and the process will be pass on SN2 mechanism. It will follow SN2 pathway. Here is in this case this sulfonate group, the sulfonate group is electron withdrawing group, so that's why they get partial negative charge, the bond become polarized, while this carbon will get partial positive charge, so that's why this carbon will be act as a electrophile and the methoxy group, the lone pair of methoxy will be attack on this carbon, so that's why the sulfonate group will be left when the attack occurs. So here transition state will be produced. That is the cyclic transition state. The transition state will be like this. This is the methyl, which is this methyl, this methyl O, this is, yeah, it will be like this. This is methyl CH3 and oxygen have plus charge because oxygen donate lone pair, and we know that the atom or the molecule that donate lone pair, it will be get, when they donate electron it will be get positive charge, when they accept electron it will be get negative charge. Why here it donate electron, so that's why it get positive charge. Plus SO2, SO3 also generate in the form of negative charge, the anion will be produced. After that the intermolecular attraction will be occur. It will be intermolecular attack will be occur because, and also this will be pass SN2 mechanism. Why it will be SN2 mechanism? Because here is attack of nucleophile and here in first step it is it follow the SN2 mechanism because it follow when the nucleophile attack on any electrophile. After that with the same time as the nucleophile attack on electrophile, at the same time the leaving group will be left the electrophile, at the bond between electrophile and leaving group it will be break down when the nucleophile attack on the carbon, so that's why they follow SN2 mechanism. Means is electrophile and nucleophile in first step, electrophile, nucleophilic and electrophilic attack will be present. So here also electrophilic and nucleophilic attack present, that's why it follow SN2 mechanism. While in second step also SN2 mechanism follow because here is intermolecular, means here is this molecule of solvents. Here let's suppose we use solvents of HOR, this is alcohol. Let's suppose this is methanol CH3, this is methanol. So in case of methanol, when we use this as a solvent, so here in this case here will be the nucleophile attack on the electrophilic carbon. This will be electrophilic carbon because this bond to get the stability, to remove the positive charge, to move the ion, to remove the positive charge. So that's why this nucleophile will be this, the solvent will be attack on this carbon. After that the oxygen will become stable and it produce CH3, it will be OHCH3. Yeah, it will be like that. So it is the stable compound, but here is also plus charge and oxygen atom. Again this will be in both cases inversion product will be produced, inversion product, because here is also nucleophile attack from the back side of the leaving groups, and in second step also nucleophile attack from the back side of the leaving groups, from the leaving bond. So that's why in both cases inversion will be present. While in both cases when inversion present, when there is inversion occur, when two times inversion occur in the same molecule, the net product to the first to the reactant, it will be it will be the retention product. It will be the retention like this. This is the this will be the final product, will be the final bond, will be the final molecule that attach to the reactant, to the first reactant. It will be add from the position from where the leaving group left, from where the sulfonate group left. So this is from this position, sulfonate group left the system, while in last methanol also attached from this position. So that's why the final product will be the retention product. I hope the point will be cleared. So this is the retention product. But in after this step, deprotonation will be occur. Deprotonation is due to of the again next the solvent will be attack. The solvent will be deprotonate this system. Means the solvent will be attack like this is CH3OH. OH. This will be attack on this hydrogen. It will remove hydrogen is a proton. So the final product will be produced OCH3. This is the final product of the system, and it is due to this reaction will be 2000 times faster, 4000 times faster when there is no methoxy group as a neighboring group attached. When there is no oxygen group attached as a neighboring, it means that neighboring group effect is most important to increase the rate of the reaction, to increase the speed of the reaction. So that's why this reaction will be very faster, because first the intramolecular attack will be occur due to the neighboring group, that is oxygen, and it will generate final products. I hope this point will be clear. Let's start the sulfur. Sulfur is a neighboring groups. Now I am cleaning the board. You can take screenshot from the video from the board, or you can rewind the video. When sulfur used as a neighboring group, when sulfur used as a neighboring group, when sulfur used as a neighboring group, what will be the effect of sulfur as when used as a neighboring group on the reaction, on the speed of the acid-2 reaction? It will be follow acid-2 reaction. How? Let's start the reaction. The reaction will be like this. When sulfur used, let's suppose this is the reaction of ethyl S. When sulfur used as a neighboring group, this is the leaving group, sir. This is the leaving group. The chlorine is leaving group, sir. While this sulfur will be act as a neighboring group because it is near to the chlorine. It will be act as a nucleophile. This lone pair that are on sulfur, it will be act as a nucleophile and attack on the electrophilic carbon that become electrophile due to the attach of electronegative elements. That is chlorine. Chlorine is most electronegative element. That's why it withdraw electron and gets partial negative charge on themselves, while it polarize the bond, and this carbon will be get partial positive charge. So that's why this carbon will become act as the electrophile, and this lone pair can be attack on this carbon easily. Also this attack will be intramolecular SN2 reaction. Why it will be SN2 reaction? Because here is also leaving group left the system, while attack of nucleophile occur, both are at same time. So that's why in SN2 reaction we know that in SN2 reaction the nucleophilic attack will be present at the same time, and at the same time the leaving group will also be left the system. So both are present here. So that's why it will follow SN2 mechanism, while the system will be intramolecular, because inside the molecules nucleophile and electrophile both are present. So intramolecular attack, and this reaction will be fast reaction. Also in this system chlorine will be removed from the system as a negative. This sulfur will be the lone pair, and this sulfur will be attacked on this electrophilic carbon. After that this bond will be removed toward chlorine. At this bond, this electron will be shifted toward chlorine, and chlorine will be lost and removed as a electronegative, as a negative ion, is an anion. And also intermediate product will be produced in the cyclic form. It will be like this. This is the one carbon, this is the another carbon, this is the another this carbon of, and also this bond will be formed because of to donate this lone pair. So that's why sulfur donated electron lone pair, so that's why that will be get positive charge because it lose electrons. And this is the intermediate three member ring are present as sulfonium ion, also called, this is also called, this intermediate is also called sulfonium ion, sulfonium ion. After that, once again SN2 mechanism will be followed. Here in this case, the solvent will be attack on this sulfur and this carbon, because to get stable sulfur, to remove the stability of this ion. The solvent will be act here, water is act as a solvent, and the solvent will be act as a nucleophile, the solvent will be act as a nucleophile, while here is intermolecular attack will be present, intermolecular attack will be present, intermolecular SN2 will be present, because intermolecular, because the nucleophile and electrophile both are different, not from the one molecule, both are different atoms. So here this molecule, this lone pair will be attack on this carbon to getting positive charge. This nucleophile can be attack on this carbon as well as can attack on this carbon, and both carbon it can be attack and give, and it will be give positive, it will be give stable product. The product, this bond will be shift toward this positive charge, and the positive charge becomes stabilized, and the final product will be like this, HSOH. This will be positive charge, this hydroxyl, this water will be get positive charge due to at lose electrons, after that this is the second step. After that, deprotonation will be occur. Deprotonation will be due to the solvent will be attack once again on one hydrogen of water, and deprotonate and lose the proton, and to give the most stable product, C2H5SOH, alcohol become produced, thiol alcohol. So this is the final stable product, while proton will be loose by the system, it will be deprotonated. Here in this system, in first step retention, in first step inversion will be produced. Why inversion will be produced? Because the nucleophile will be attacked from this back side of the leaving groups, while in second step nucleophile also attack from the breaking of carbon, from the back of the dead bond that are break. So that's why in both cases inversion will be present, inversion will be occur. While we know that when two times inversion occur, the final product will be retention product to the original position, to the original reactant. It will be retention because from this side it will be like this, OH. Here is also, sorry, because I missing one carbon, OHH. Yeah, to the final product, the final product will be retention, because here from this side the leaving group left the system, while from this side again in next position, from this side from where the leaving group left, the final product, the nucleophile will be attached from this side. So that's why the final product will be the retention product to the original system. I hope the point will be cleared. This is all about inversion. And due to the sulfur is a neighboring group, when there is no sulfur, the reaction will be not enough speed, not enough faster as compared to when sulfur is used. When there is sulfur at use at increase, when sulfur is a neighboring group, at increase the speed of the reaction almost 10 power 3 times when there is a, then as compared to when there is no sulfur group, when there is no sulfur group, no sulfur atom is a neighboring group attached, is a neighboring group. I hope the point will be cleared. Okay, let's move toward nitrogen as a neighboring group. When nitrogen act as a neighboring group, nitrogen act as a neighboring group, what will be the effect of nitrogen when act as a neighboring group on the speed of SN2 reaction, on the rate of the SN2 mechanism? Let's start. Let's do one example on this. C2H5N, C2H5, C2H5Cl. This is the one product, this is the one compound in which both leaving group, in which two electronegative element present, one is chlorine and one is nitrogen. Chlorine will be act as a leaving group, it will be left the system, while nitrogen is neighbor to this chlorine, so that's why this nitrogen will be act as a nucleophile. The lone pair on this nitrogen will be attack on this carbon that are polarized by chlorine, that are bonded with chlorine. Why it become polarized? Because chlorine is most electronegative elements, that's why chlorine will be get partial positive charge, it will get partial positive charge, partial negative charge, because it withdraw the electron from the carbon, from this bond, so that's why the carbon will be get partial positive charge and will be act as electrophile, so that's why this lone pair will be attack on this electrophilic carbon, and the bond will be shift towards chlorine, and chlorine will be removed, chlorine will be lose the system, the chlorine will be removed from the system and lose by the system as a chlorine negative ion. So in first step, it will be intramolecular attack, intramolecular SN2. Why it will be intramolecular SN2? First of all, it is SN2 reaction, because both nucleophile attack on the electrophilic carbon, while at the same time chlorine also leaving the group, so that's why when both are present, it will be called SN2 reaction. When the leaving groups and the attack of nucleophile, it is occur in the same time, so this will be the reaction will be SN2 reaction. While also it is intramolecular, because inside in one molecule the nucleophile and electrophile is present, or nucleophile will attack on electrophilic carbon, and it generate the positive intermediate, that is nitronium ion, or you can say that is a DNM ion, and chlorine will be lose as a negative, chlorine will be lost as a negative, so the product, not the product, it will be the intermediate C2H5 in C2H5, it will be, here is C2H5, and this due to attack of this carbon, this lone pair on this carbon, so their hair bond will be present. Due to the loss of the electron, due to the loss of the electron, the nitrogen will be get positive charge, because it lose electron, it donate electron to this carbon. So here in this case one hydrogen is also present to this carbon. So in this case, this is the intermediate, this is the intermediate azardinium ion, this is also, this is the intermediate product, this is intermediate, and we know that the intermediate is unstable. After that, the intermolecular SN2, another step, intermolecular SN2 means another outside from the molecule, another molecule will be attack on this. SN2 attack will be present. At this attack will be the attack of solvents on this carbon to getting to getting the stability, to removing the positive charge from the system. So this attack will be occur of the solvents. This is when H2O act as a solvent. This we know that this oxygen contain two lone pair. This will be attack on this carbon. So that's why the bond will shift toward this nitrogen, and nitrogen become neutral. C2H5 in C2H5, it will become C2H5 OH. This oxygen will get positive charge because it lose the electron, it donate the electron, so that's why it will positive charge. After that deprotonation will be occur in next step to getting the final products. Why deprotonation? Because to getting the stable product, to removing to removing this positive signs. After that, once again the solvent attack occur. Solvent will be attack on this carbon. Not solvent will be attack on this carbon. Here this the chlorine that is removed from the system, this is negative. This can be attack on this carbon and getting positive stable ion and producing generating stable compound C2H5 in C2H5 C2H5 OH. This will be the final product. Also generate HCl. Means here hydrogen will be as a proton, it will be removed, plus HCl product will be formed. Here sorry, in the first step, in the when sulfur using as a neighboring group, here is not the hydroxyl attack, not the solvent attack. This chlorine will be attack on this hydrogen and produce generating the final product. Also HCl will be produced. This is the mechanism of when sulfur used as a neighboring group, when hydrogen used as a neighboring group, when oxygen used as a neighboring group, when halide use a when halide as a neighboring group. So that's why it will have different rate, it will increase the rate of the SN2 reaction. I hope today's topic will be cleared. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there. Okay, thank you very much. Please also subscribe my channel. It makes me feel happy that my students are supporting me. Okay, thank you. Very best of luck, my dear student. Very best of luck.